Hello, so I'm home again now and in the comfort of home outside of the wind, and so I can continue and hopefully complete chapter 3. So the last thing I talked about was the definition, or as I say, the explanation of what it is a person is, according to David Deutsch. Those entities that can create explanatory knowledge, and I spent a vast amount of time on this. And I probably waxed lyrical a little too much. So I'm going to skip forward a number of pages and move towards the second half, really, of the chapter. It's a very long chapter. And I'm going to just jump over sections such as, for example, where David distinguishes between explanatory knowledge, genetic knowledge, and there's a third type, which he calls cultural knowledge. And cultural knowledge is, of course, the way it sounds. It is the knowledge that is embedded within a culture in some way. It's this inexplicit type knowledge. There's also a sense in which other animals have cultural knowledge as well. And so we're going to come to see, and this is the reason I'm passing over it, in chapter 16, a cultural knowledge of a sort that, for example, great apes have, where they're able to behavior pass. And behavior passing is where knowledge can be passed on from one generation to the next via a culture. So there are memes there that are being transmitted from one place to the next, but it's not explanatory. Now, it's very interesting. It's a nuanced argument, but it says that there are certain kinds of knowledge that can be passed from one generation to another in great ape species that isn't encoded entirely in their genes, but can't be divorced from their genes either. Kind of like us, but it's not explanatory and it's not universal. We'll get there in chapter 16, so for now I'm going to skip over the part of chapter 3 where it's mentioned. So now let's get to a new part of chapter 3. And David writes, "One might wonder whether the reach of people in general might be greater than the reach of humans. What if, for instance, the reach of technology is indeed limited, but only to creatures with two opposable thumbs on each hand? Or if the reach of scientific knowledge is unlimited, but only to beings whose brains are twice the size of ours? But our faculty of being universal constructors makes these issues as irrelevant as that of access to vitamins. If progress at some point were to depend on having two thumbs per hand, then the outcome would depend not on the knowledge we inherit in our genes, but on whether we could discover how to build robots or gloves with two thumbs per hand, or alter ourselves to have a second thumb. If it depends on having more memory capacity or speed than a human brain, then the outcome would depend on whether we could build computers to do the job. Again, such things are already commonplace in technology." So this is the argument I hear frequently from popularizers of science, physicists especially, who are interested in questions of astrobiology and whether there are aliens out there or not. And the argument is about the extent to which the laws of physics, as I mentioned in my last video, the extent to which the laws of physics might be incomprehensible to us, but comprehensible nonetheless to some other kind of intelligent life form out there. So there might be these super intelligent aliens, or indeed the superintelligence of the form that the AI catastrophists are concerned about. So this is the Nick Bostrom flavour of pessimist, technological pessimist, who argues that the AGI could turn up, or it's not an AGI really. I've written a blog about this. It's sort of a super AI, a conniving sort of AI that might decide to take over humanity, either because of malevolence or because it's simply uncaring and wants to convert everything into paperclips, and having been told to convert everything into paperclips, refuses to stop. Whatever the case, there might be these kind of super intelligences that are able to comprehend things in the universe, physical laws, that our brains don't allow us to. And David has just explained there how that can't be possible, because the only things that can be augmented could be the speed and memory capacity, and those things we already routinely do. I'll continue. David speaks along similar lines now. He says, "The astrophysicist Martin Rees has speculated that somewhere in the universe there could be life and intelligence out there in forms we can't conceive. Just as a chimpanzee can't understand quantum theory, it could be there are aspects of reality that are far beyond the capacity of our brains. I'll just pause there and add a little personal anecdote. My father says exactly the same thing. He says that attempting to understand God is like a chicken trying to understand a human. And I've always found this objectionable because of this idea of being able to comprehend stuff if it can be put into words. And so if it can be put into words for a god or for a super alien intelligence in their language, then it can be translated into our language and we can understand it. Anyway, we'll continue with what David has to say here. David writes, "But that cannot be so. For if the capacity in question is mere computational speed and amount of memory, then we can understand the aspects in question with the help of computers, just as we have understood the world for centuries with the help of pencil and paper. As Einstein remarked, 'My pencil and I are more clever than I.' In terms of computational repertoire, our computers and brains are already universal. But if the claim is that we may be qualitatively unable to understand what some other forms of intelligence can, if our disability cannot be remedied by mere automation, then this is just another claim that the world is not explicable. Indeed, it is tantamount to an appeal to the supernatural, with all the arbitrariness that is inherent in such appeals. For if we wanted to incorporate into our worldview an imaginary realm explicable only to superhumans, we need never have bothered to abandon the myths of Persephone and her fellow deities." I'll pause there, this is me speaking again. This is wonderful. So when in a discussion about these issues among scientifically minded people, you encounter this objection that a person is trying to think hard and rationally about these issues and whether or not aliens are out there and whether or not the world is comprehensible and whether or not there's super intelligence out there, one thing to keep in mind is if someone argues that there could be realms out there that are inexplicable to us, but explicable either to super intelligent aliens or to super intelligent artificial intelligence, then what they're saying is that there are realms, regions of the universe, laws of physics, that essentially are as inexplicable to us as a supernatural being would be. And so the argument is precisely the same. Instead of having God being the thing that cannot be explained by the human mind, you're just replacing your supernatural God with a supernatural alien or a supernatural technology. They're serving exactly the same function. They're arguing that certain things can't be understood by human beings. So let's continue. David writes, "So human reach is essentially the same as the reach of explanatory knowledge itself. An environment is within human reach if it is possible to create an open-ended stream of explanatory knowledge there. That means that if knowledge of a suitable kind were instantiated in such an environment in suitable physical objects, it would cause itself to survive and would then continue to increase indefinitely. Can there really be such an environment? This is essentially the question that I asked at the end of the last chapter. Can this creativity continue indefinitely? And it is the question to which the spaceship Earth metaphor assumes a negative answer." Okay, so now David moves into explicitly writing about the content of one of his TED Talks. This amazing insight he gives that anywhere in the universe could be a potential hub of knowledge creation, of open-ended knowledge creation. He says there's only three things that you need. So I won't read the entire chapter here, I'll just pick out a few key points. So he says what's needed for this open-ended creation of knowledge is firstly matter. We need to get matter. And he also argues the reason why we need matter is so that we can power everything. So if we want to power our knowledge creation, we're going to need some form of energy, and that requires matter. And we're going to need somewhere to store the knowledge that we create, and that's going to require matter. We're also going to need evidence. We're going to need to be able to find out about the world. So the evidence comes flooding in. And so when we start to create our knowledge, we need to test our theories. And the way to test our theories is by recourse to comparing our theories against the evidence, or we have competing theories to see which one is ruled out by the evidence. That's the purpose of evidence. So these are the things that we need. We need matter and evidence. So he says matter, energy, and evidence. Matter is energy, right? According to Einstein's theory of general relativity, we can convert one into the other, so that's no problem. And he writes, matter, energy, and evidence are the only requirements that an environment needs to have in order to be a venue for open-ended knowledge creation. Isn't that amazing? In other words, just about anywhere in the universe, even intergalactic space, where all of those things are at their lowest possible values. There's the least amount of matter, energy, and evidence is out there in intergalactic space. But there is matter and energy out there, and there is evidence coming in. All you need is a moderate-sized telescope, as he points out. So if we want to transform any part of the universe into a hub of knowledge creation, we can do so if we know how, if we can figure out how. I'm skipping a bit. So now he's speaking about once you have this matter, energy, and evidence, what can you do with it? You can have an open-ended stream of knowledge creation. What does that mean? Well, it could mean converting things into space colonies where people can be in order to create the knowledge. We might start at the moon. So he writes, setting up self-sufficient colonies on the moon and elsewhere in the solar system, and eventually in other solar systems, would be a good hedge against the extinction of our species or the destruction of civilization, and is a highly desirable goal for that reason, among others. As Stephen Hawking has said, I don't think the human race will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life in a single planet, but I'm an optimist. We will reach out to the stars. End quote. David writes, but even that will be far from an unproblematic state, and most people are not satisfied merely to be confident in the survival of the species. They want to survive personally. Also, like our earliest human ancestors, they want to be free from physical danger and suffering, skipping a little. In fact, people will always want still more than that. They will want to make progress. For in addition to threats, there will always be problems in the benign sense of the word, errors, gaps, inconsistencies, and inadequacies in our knowledge that we wish to solve, including, not least, moral knowledge. Knowledge about what to want, what to strive for. I'm just going to pause there. This is another place that David Deutsch provides a parsimonious, true, and refined way of getting at the heart of what morality is about. So many people now are concerned about what are the moral foundations of civilization. They are concerned that if we, or in many cases, they're concerned about giving up religion, because if we give up religion, then we're free of a moral foundation. Others say, well, now that we've had religion, we've tried that, now let us look for a new moral foundation. Once more, David provides this third way. We don't have to be concerned about moral foundations in religious moral foundations, and we don't need to be concerned about secular moral foundations. We don't have to be concerned about moral foundations. He'll get to a part about what morality essentially consists of and how to ensure that we can continue to improve our morality and make progress in morality, just as anywhere else. But here, he's hinting about how morality is different to other areas. Now, other areas are relevant to making moral decisions, but what morality is about, so I'll repeat what David has said there, is that morality or moral knowledge is knowledge about what to want, what to strive for. So it's about the should, it's about the future, it's about what we are trying to achieve, what we should want. We always have a very large, possibly infinite repertoire of things before us that we could choose to do. Morality is about which one should we choose. Do we need foundations for this? We don't. What we need is a stance of error correction. But I'm getting ahead of myself. We'll leave that for future chapters. So let's continue. David writes, here is another misconception in the Garden of Eden myth, that the supposed unproblematic state would be a good state to be in. Some theologians have denied this, and I agree with them. An unproblematic state is a state without creative thought. Its other name is death. This is fantastic. This is the idea of utopias, whether they're religious utopias. So I think people like Christopher Hitchens would have complained that heaven, as it is normally spoken about in monotheism, sounds like a terribly boring place. And I would agree. Not only terribly boring, it sounds awful. You're under perpetual surveillance, apparently, by this all-seeing God. But nothing ever changes because everything's perfect. So too in political utopias. This idea that we can finally, once and for all, grok the ultimate political system such that everything is working in its best possible way, or its most perfect way. Instead, if we simply have an understanding that people are fallible, so their institutions are fallible, and what we should be striving for is incremental improvement, things tend to go a lot better. We don't tend to have bloody revolutions. We improve things where we can, and we improve things slowly, such that we can correct the errors when we make missteps. But striving for utopias is a bad idea. Striving for unproblematic states is striving for somewhere where we do not have to correct errors anymore, because all the errors have been corrected. And that sounds like hell rather than heaven or any kind of utopia. Let's continue with chapter 3. David writes, "Nor will we ever run out of problems. The deeper an explanation is, the more new problems it creates. That must be so, if only because there could be no such thing as an ultimate explanation. Just as the gods did it is always a bad explanation, so any other purported foundation of all explanations must be bad too. It must be easily variable, because it cannot answer the question, why that foundation and not some other? Nothing can be explained only in terms of itself. That holds for philosophy, just as it does for science, and in particular, it holds for moral philosophy. No utopia is possible, but only because our values and our objectives can continue to improve indefinitely." We're about to get to the part that not only is the most famous part of the chapter, but it's possibly the most famous part of the book. There are many famous parts of the book, but this one really stands out. So let me just read it. He writes, "Thus, fallibilism alone rather understates the error-prone nature of knowledge creation. Knowledge creation is not only subject to error, errors are common and significant and always will be, and correcting them will always reveal further and better problems. And so the maxim that I have suggested should be carved in stone, namely the Earth's biosphere is incapable of supporting human life, is actually a special case of a much more general truth, namely that, for people, problems are soluble. So let us carve that in stone. Problems are inevitable. It is inevitable that we face problems, but no particular problem is inevitable. We survive and thrive by solving each problem as it comes up. And since the human ability to transform nature is limited only by the laws of physics, none of the endless stream of problems will ever constitute an impassable barrier. So a complementary and equally important truth about people and the physical world is that problems are soluble. By soluble, I mean that the right knowledge would solve them. It is not, of course, that we can possess knowledge just by wishing for it, but it is in principle accessible to us. So let us carve that in stone too. Problems are soluble." So this is very famous, and people speak about this, and sometimes as a criticism of David's philosophy, and it's a mistaken criticism. David is a fallibilist, but they find this grating in some way that he's carved things in stone. I think John Horgan perhaps made this criticism, or some others have done it in print as well. This idea that one would carve things in stone sounds somewhat ridiculous and religious, but I find it a quaint idea, and it's a way of emphasizing this magnificent dichotomy. It also underpins constructor theory, a fully fledged scientific theory, and so it's important to have these principles that underlie our rationality and our reason. It doesn't mean that they cannot possibly be criticized. It doesn't mean they're not fallible. It simply means that they're a good way in order to arrange our reason, in order to approach problems in an optimistic way. So this provides a basis, not an unalterable foundation. They provide a basis or a framework within which we can operate. It's an infinite-sized framework, okay? The idea that problems are inevitable and problems are soluble. So the criticism is more a criticism of approach rather than... The criticism of David on this point, I think, is nothing but a criticism of approach or of style rather than anything to do with substance. So I'll continue. That progress is both possible and desirable is perhaps the quintessential idea of the Enlightenment. It motivates all traditions of criticism, as well as the principle of seeking good explanations, but it can be interpreted in two almost opposite ways, both of which, confusingly, are known as perfectibility. One is that humans, or human societies, are capable of attaining a state of supposed perfection, such as the Buddhist or Hindu nirvana, or various political utopias. The other is that every attainable state can be indefinitely improved. Fallibilism rules out the first position in favour of the second. Okay, so everything can be improved. There's no such thing as heaven or nirvana or a utopia. Now there proceeds to be some lengthy discussion, and it's worthwhile reading. Get the book and read the book, but about the history of the Enlightenment. And it's very interesting. I personally find it very interesting because I just happen to be interested in the history of philosophy. But it's essentially about these esoteric matters of the difference between continental, French-style, German-style Enlightenment thinking, and British-style Enlightenment thinking. And David points out that the continental style seemed to be seeking final answers and utopias, and the British style recognised the more fallibilist nature of the human condition and human beings. Then there's another lengthy section, which David definitely drew from in order to frame his TED Talk. It was the one that got the biggest laugh, if I remember, where he speaks about the matter, energy and evidence out there in intergalactic space are all there at their lowest possible supply. So it's completely empty. And then he says, or is it? That is another parochial misconception, and people laugh because it's so astounding. It's such an astounding idea that you're about to hear something astonishing, namely that even this implacably dark and empty place is going to turn out to be a potential hub of knowledge creation. That's fantastic. So I'll continue after missing those two significant sections. He writes, all people in the universe, once they have understood enough to free themselves from parochial obstacles, face essentially the same opportunities. This is an underlying unity in the physical world, more significant than all the dissimilarities I have described between our environment and the typical one. The fundamental laws of nature are so uniform, and evidence about them so ubiquitous, and the connections between understanding and control so intimate, that whether we are on our parochial home planet or 100 million light years away in intergalactic plasma, we can do the same science and make the same progress. So a typical location in the universe is amenable to the open-ended creation of knowledge. And therefore, so are almost all other kinds of environment, since they have more matter, more energy, and easier access to evidence than intergalactic space. The thought experiment considered, almost the worst possible case. Perhaps the laws of physics do not allow knowledge creation inside, say, the jet of a quasar, or perhaps they do. But either way, in the universe at large, knowledge friendliness is the rule, not the exception. That is to say, the rule is person friendliness to people who have the relevant knowledge. Death is the rule for those who do not. Skipping some more, and now I get to one of my favourite parts of this entire chapter, and something that I've prefaced previously in the last two parts of this chapter. So let me just read quite a lengthy section here now. He writes, now I can turn to the significance of knowledge, and therefore of people in the cosmic scheme of things. Many things are more obviously significant than people. Space and time are significant because they appear in almost all explanations of other physical phenomena. Similarly, electrons and atoms are significant. Humans seem to have no place in that exalted company. Our history and our politics, our science, art and philosophy, our aspirations and moral values, all these are tiny side effects of a supernova explosion a few billion years ago, which could be extinguished tomorrow by another such explosion. Supernova, too, are moderately significant in the cosmic scheme of things. But it seems that one can explain everything about supernova and almost everything else without ever mentioning people or knowledge at all. However, that is merely another parochial error due to our current untypical vantage point in an enlightenment that is mere centuries old. In the longer run, humans may colonize other solar systems and, by increasing their knowledge, control ever more powerful physical processes. If people ever choose to live near a star that is capable of exploding, they may well wish to prevent such an explosion, probably by removing some of the material from the star. Such a project would use many orders of magnitude more energy than humans currently control, and more advanced technology as well. But it is a fundamentally simple task, not requiring any steps that are even close to limits imposed by the laws of physics. So with the right knowledge, it could be achieved. Indeed, for all we know, engineers elsewhere in the universe are already achieving it routinely. And consequently, it is not true that the attributes of supernova in general are independent of the presence or absence of people, or of what those people know and intend. More generally, if we want to predict what a star will do, we first have to guess whether there are any people near it, and if so, what knowledge they may have and what they may want to achieve. Outside our parochial perspective, astrophysics is incomplete without a theory of people, just as it is incomplete without a theory of gravity or nuclear reactions. Note that this conclusion does not depend on the assumption that humans or anyone else will colonize the galaxy and take control of any supernova. The assumption that they will not is equally a theory about the future behavior of people. Knowledge is a significant phenomena in the universe because to make almost any prediction about astrophysics, one must take a position about what types of knowledge will or will not be present near the phenomena in question. So all explanations of what is out there in the physical world mention knowledge and people, if only implicitly. But knowledge is more significant even than that. Consider any physical object, for instance, a solar system or a microscopic chip of silicon, and then consider all the transformations that it is physically possible for it to undergo. For instance, the silicon chip might be melted and solidify in a different shape, or it might be transformed into a chip with a different functionality. The solar system might be devastated when its star becomes a supernova, or life might evolve on one of its planets, or it might be transformed using transmutation and other futuristic technologies into microprocessors. In all cases, the class of transformations that could happen spontaneously, in the absence of knowledge, is negligibly small compared to the class that could be affected artificially by intelligent beings who wanted those transformations to happen. So the explanations of almost all physically possible phenomena are about how knowledge would be applied to bring these phenomena about. If you want to explain how an object might possibly reach a temperature of 10 degrees or a million, you can refer to spontaneous processes and can avoid mentioning people explicitly, even though most processes at those temperatures can be brought about only by people. But if you want to explain how an object might possibly cool down to a millionth of a degree above absolute zero, you cannot avoid explaining in detail what people would do. And that is still only the least of it. In your mind's eye, continue your journey from that point in intergalactic space to another, at least 10 times as far away. Our destination this time is inside one of the jets of a quasar. What would it be like in one of those jets? Language is barely capable of expressing it. It would be rather like facing a supernova explosion at point blank range, but for millions of years at a time. That is the best explanation, that is the best description of a quasar that I have read, and I have read a lot of astrophysics books before. So let's continue. The survival time for a human body would be measured in picoseconds. As I said, it is unclear whether the laws of physics permit any knowledge to grow there, let alone a life support system for humans. It is about as different from our ancestral environment as could possibly be. The laws of physics that explain it bear no resemblance to any rules of thumb that were ever in our ancestors' genes or in their culture. Yet human brains today know in considerable detail what is happening there. We're about to get to this amazing relationship between the laws of physics and structures out there in the universe and our brains. A connection is made here that has never been made before. So let me read. David writes, of the quasar jet. Somehow that jet happens in such a way that billions of years later, on the other side of the universe, a chemical scum can know and predict what the jet will do and can understand why. That means that one physical system, say an astrophysicist's brain, contains an accurate working model of the other, the jet. Not just a superficial image, though it contains that as well, but an explanatory theory that embodies the same mathematical relationships and causal structures. That is scientific knowledge. Furthermore, the faithfulness with which the one structure resembles the other is steadily increasing. That constitutes the creation of knowledge. Here we have physical objects, very unlike each other, and whose behavior is dominated by different laws of physics, embodying the same mathematical and causal structures, and doing so ever more accurately over time. Of all the physical processes that can occur in nature, only the creation of knowledge exhibits that underlying structure. Wow, that's amazing. So he's just said, picking possibly the most alien kind of environment that we can presently think of, a quasar jet, where, as far as we know, theoretically, it's powered by a rotating black hole that's spinning so fast that the magnetic fields cause the material that is spiraling into the black hole to be shot out because of the magnetic fields in great jets. And these jets, as far as I remember, the matter in those jets is accelerating away from the black hole at close to relativistic speeds. So it's kind of like a particle accelerator, but at ridiculously high energy. And so if you were to stand inside of that jet, as David said, it'd be something like experiencing a supernova blast. It'd be something like experiencing a supernova blast. Whatever the case, it is an environment completely unlike the human brain. The human brain is a wet, 36 degrees Celsius object, rather complicated. A quasar jet is millions, billions of degrees Celsius, traveling at relativistic speeds. The human brain is not. They're completely different, the quasar jet and the human brain. And yet, what's going on inside of that quasar jet is replicated inside of the astrophysicist's mind in terms of the relationships between the entities that are involved creating the phenomena. So in the quasar jet, what's going on is a bunch of physical relationships between black holes, magnetic fields, light, matter. What's going on inside of the brain is a bunch of relationships as well, but these are abstract relationships representing the physical ones that are out there. And as we create more knowledge, the model, the theory, the explanation that's inside of an astrophysicist's brain of what a quasar is represents the quasar with ever greater accuracy. So this is what scientific knowledge is. Scientific knowledge is where we embody mathematical relationships, we embody explanatory relationships, abstract ones, inside of our minds that represent the mathematical and causal relationships of things out there in the universe. And as that increases, as that improves or becomes more accurate, that's what we call the creation of knowledge. Wow. Okay, so that's a really impressive way of looking at things. Okay, so now I'm going to skip a bit more, but David also speaks about how physical processes in general, when we're trying to predict what's going to happen, we really have to consider the knowledge that happens to be present at any particular location. And he uses the quaint example of the SETI project. And the Arecibo telescope is in Chile, and it is part of the SETI project, the Search for Extraterrestrial Intelligence. And in a fridge at the Arecibo telescope is a bottle of champagne, which will be opened one day if they find evidence of alien intelligence out there somewhere using the radio telescope. So normally, if you're trying to predict if a gas-filled bottle is going to explode, you use equations from physics, equations from chemistry. We'll use something called the universal gas law. Universal gas law is PV equals nRT. P is the pressure, V is the volume, N is the number of moles, R is the gas constant, T is the temperature. And you can solve this equation, and you can, if you already know what pressure is required in order to release the cork from a bottle, well, you can make a prediction about when that cork is going to be released from the bottle. If we start to heat the bottle up, given its volume and the pressure that's inside already and the pressure that's outside and etc., you get what I'm saying, you can make a prediction of when the cork will flip off the bottle. But if you're talking about that particular bottle in that particular fridge, then no amount of physics and chemistry and thermodynamics expertise is going to allow you to make that prediction. David writes of whether or not the cork is going to pop out of the bottle. He writes, to predict it, you have to know whether there really are people sending radio signals from various solar systems. To explain it, you have to explain how people know about those people and their attributes. Nothing less than that specific knowledge which depends among other things on subtle properties of the chemistry of the planets on distant stars can explain or predict with any accuracy whether and when that cork will pop. So I basically reached the end of this fantastic chapter. It's an amazing read. The entire thing is an amazing read. I've taken something like 2 hours to read the entire thing. So let me just read the conclusion. David writes about how, as far as we know, only here on Earth is there a hub of knowledge creation. That nowhere else in the universe is knowledge being created. And knowledge is a cosmically significant thing for all the reasons that he's explained in this chapter. But the rest of the universe can become a knowledge creating hub just like the Earth is. All it needs is a spark. And he writes, like an explosive awaiting a spark, unimaginably numerous environments in the universe are waiting out there for eons on end, doing nothing at all, or blindly generating evidence and storing it up or pouring it out into space. Almost any of them would, if the right knowledge ever reached it, instantly and irrevocably burst into a radically different type of physical activity, intense knowledge creation, displaying all the various kinds of complexity, universality and reach that are inherent in the laws of nature, and transforming that environment from what is typical today into what could become typical in the future. If we want to, we could be that spark. Wow, amazing. He has a section at the end of every chapter that contains terminology. I don't think I'll always read this. I didn't read it for chapter 1, I didn't read it for chapter 2, but I just want to pause and reflect on some of the terminology used in this particular chapter, as it will become relevant in subsequent chapters. So he defines a person, if you remember, and this is from the last episode, he defines a person as an entity that can create explanatory knowledge. He talks about fundamental or significant phenomena as one that plays a necessary role in the explanation of many phenomena, or whose distinctive features require distinctive explanation in terms of fundamental theories. Parochialism is mistaking appearance for reality, or local regularities for universal laws. A constructor is a device capable of causing other objects to undergo transformations without undergoing any net change itself. A universal constructor is a constructor that can cause any raw materials to undergo any physically possible transformation given the right information. So this is foretelling constructor theory. There's a whole website now for constructor theory, www.constructortheory.org, which you should visit. There are some fantastic videos there. There are excellent papers that have been written. And this really shows a huge amount of promise. It's a new mode of explanation. It's a new way in which we can make progress in physics. Many people have recognized, I think increasingly physicists have recognized, that string theory, useful as it is mathematically, beautiful as it might be mathematically, isn't making the kind of progress that people assumed it would have after this many decades. So whatever the case, David's offering an alternative unifying theory, this constructor theory, that has the potential to achieve not only some of the things that string theory might have, but could be a way of looking at many other kinds of science, many other kinds of philosophy. This dichotomy between what it is possible to achieve, what is possible versus impossible. So I myself am looking forward to learning more and more about this. I'm still an amateur in this area. And so perhaps after the beginning of Infinity readings, I'll attempt to tackle some of constructor theory. Okay, thanks. Next time, chapter 4.